For polynomial functions, basically here's what we're looking at. Everything up till now, we had kind of stopped at x squared because we've been doing quadratics. We did a little bit with absolute value, which was, graph-wise was similar to quadratics, but a little bit different. But now we're doing polynomial functions. This is where we're going past x squared. Now we're looking at x to the third, x to the fourth, x to the fifth, x to any power really is what it comes down to. So, we're going through this. The first part's what we're going to do here. This is going to be like really easy in the beginning because it's going to be, really, really, really simple because of you're just naming stuff. So there's not really anything you have to do other than just kind of looking at it to see what it is that we're doing here. So first thing they're going to ask you to do, remember that when we talk about polynomial functions, before we talk about the first thing here, when we talk about terms of polynomial functions, just realize those are always separated by a plus or a minus. That if you want to think about terms that they're separated by a plus or minus, these should all have a different power of the variable, different power of x. We think about that way. That if we happen to have, most of the time they're only going to have one variable. If they happen to have two variables, you got to realize that each term has a different variable or variable's power. So, if you happen to have an x squared and an x squared, you would combine like terms to make it just to be one term for that thing. So, I guess if you want to think about what terms are and how they're going through that, and that's kind of the big thing we're looking at. Okay, so the very first thing they're going to ask you to do, and again, y'all have seen this before, or at least I hopefully you have. With COVID, we don't really know by this case, but hopefully get here. First thing they're going to ask you to do is they're going to ask you to name by the number of terms. Okay, if it's a monomial, okay, that's one term. That'd be just, if you had 4x squared, that's a monomial. If we were going back to quadratics, 4x squared would have been a monomial because there's just one term that's there. All right, and after we do the second one, you'll go, oh, yeah, I know what we're talking about. If it's a binomial, pretty easy, right? Binomial means you've got two terms. So if binomial is two terms, three terms is there you go, trinomial. Yeah. It's pretty easy, right? Okay, now, and those are the only three specific ones that they do. Anything after that, it's just they just call it an n-term polynomial. If you have four or more terms, where n is the number of terms. So if you're not that you're going to get one this way, but if you went through and you counted, you had 15 terms in a polynomial, you would just call it a 15-term polynomial. So 1, 2, and 3, it seems like they'd come up with a name for 4 because we do a good bit with 4 terms, but they don't. They just say, all right, we're just going to do monomial, binomial, and trinomial, and then everything after that is you just count how many terms it has. If it's got 6 terms, you just call it a 6-term polynomial. Okay, so again, I wish they would give you one more name for a 4-term polynomial, like the quadnomial would be good, but they don't. They just say, all right, everything 4 or more, you just say it's that number term polynomial. Okay, so those are pretty easy. Monomial, binomial, trinomial. Again, after that, it's just 4 or 5 or 6 term polynomial. Just kind of name it from there. Okay, the other thing they're going to talk about is the degree. And when you talk about what a degree is, that's the highest power of a, we'll say, specified variable. Okay, and again, you have to they have to tell you which specific variable they're looking at. If they give you X and Y, they have to tell you, all right, which one of these has the degree based on, you know, whatever variable is we're looking at. Now, sometimes they may just say find the degree of a term. If that's the case, then you add all the variables together. But for most of these, they're just going to have you look at just one specific variable for what we're talking about. There's, again, other times where they talk about the degree of a term where you take all the powers of a term and put it together. But in this case, we're looking at just one variable at a time. So it's a little different if you have two variables. You have to kind of do something a little different if you have 2 or 3 variables, but we're looking at just one specific variable at a time for this thing. All right, so the name of it. And this, we're going to make a little T-chart here. So we're going to name it. Talk about what the degree of it is. And then we're going to give you an example of it. Okay, so we're going to do the name of the term, the name, or we're going to name it by degree, I guess would be the best way of saying here. So we're going to name it by the degree based on what the degree is, and then show an example of what that would be. So if we start off with degree of 0, which means that if your highest power is 0 power, if you do x to the 0 power, what's that going to be? X to the 0. Did we talk about that already? Did we talk about that? Okay, that's coming up shortly. If you do anything to the 0 power, it's just 1. We didn't talk about that yet? Okay, so that's coming. All right, we talked about that. Oh, that was in my computer science class. We talked about that. Okay, anyway. So we'll talk about that a little bit later. So if you've got something that's degree 0, they call that a constant. And if it's constant, that means it never changes, which means it would just be 4 or 14 or -7 or 2. It's just a number. That's all it's going to be. There's no variables with it. It's just a number.
Is it like going back to like the number of the power is like the number of solutions that you have?
Yep. Yeah. So so this is like the number of solutions that you have kind of thing. Yeah. Okay. So if we're going to go degree 1, think about if we were going to think about the graphs we've done so far. If we were going to have a solution that had one answer to it, which means it was going to cross the x-axis one time. Most of the cases, it was going to be a straight line. So they're going to say, in that case, we're probably looking at something that's linear. And if we talk about like equation-wise, because some of these they may do equations, so it may be like y equals 4. Just think about if we graphed the equation, it was y equals 4. Did we ever cross the x-axis? We didn't, did we? So we never got a solution. So that's why this was 0, because degree 0, meaning there wasn't actually a solution for this kind of thing. So you can kind of think about that one. If it was linear, that's your y equals mx plus b. So that would be where you have something like y equals 2x minus 5. All right, so if it's degree 2, so think about what we've been doing here. If we had degree 2, if we had 2 answers, basically that means it's going to be x squared, right? If we were doing x squared, what kind of thing was it? What were we doing? What was the name of it? The blank formula? The quadratic formula? Yeah, so if it's 2, because we're doing the quadratic formula to get 2 answers, then they say, all right, well, this is a quadratic then. Which I know sometimes people get a little confused because I thought quad means 4. Well, it does. I'm not sure where quadratic came from. It's probably some Latin root word or something that came to it. But anyway, so if you're doing that one, it could be that's y equals x squared, minus 13x plus 7 or something like that. All right, degree 3. And this one actually makes sense. If something is to the 3rd power, like if you do volume, it's length times width times height, that you multiply those together. So they call it cubic because it's cubed. It's got 3 dimensions, length, width, and height. If you want to think about it that way. So it could be this, y equals negative 2x to the 3rd minus 10. Okay, so now if we're taking quad off the board, because 2 is quadratic, if it's 4, what's something else that's always base 4? If you talk about 4 something, you have 4 of this in a dollar. You have 4 of these in a football game. Quarters, right? So in this case, this one is quartic. Yeah. Instead of quarters, it's quartic. 4 quarts in a gallon, 4 quarters in a dollar, 4 quarters in the basketball game, football game. Technically, our year's broken up into 4 quarters, right? Spring, summer, winter, fall. Never really think about it that way, but it's it's kind of that way. All right, so again, the big thing on that one is that the highest power term, the degree, is going to be x to the 4th, and everything after that doesn't really matter because it could be, minus 2x squared plus 8 or something like that. The main thing is that your highest power, your degree, is x to the 4th power. All right, and then the last one. Fifth power is quintic. So maybe something like negative 7x to the 5th minus 2x plus 3. I'm guessing that's probably got a Spanish background to it, maybe. Or again, we have to go back to the Latin root word because a lot of this were Latin stuff, so it may be that it may have come from some Latin, something other than that one. So, okay. So, okay, and again, it's just going to, basically, you're going to have a drop-down menu in Math Excel, and it's going to say, okay, name it by the number of, it may just say put in the number of terms, whether it's 1, 2, 3, 4. They may not actually have you name it. And then you'll have a drop-down menu, and it'll say, all right, pick the name that goes with it. So you have one answer that's this, you have a second answer that's this. The third answer that they may do to you is they may ask you to write something in standard form. And you've already been doing standard form. It's just nobody ever really called it that until now. I don't know why we waited till now to tell you. But standard form is where you basically write the terms in descending order. Based on the degree of each term. So you start with your highest power of x, and that's what we've always kind of done when we're doing these. When we do quadratics, it was always ax squared plus bx plus c. That was descending order. That was already standard form. And they say, okay, well, if we just take that and apply that to any polynomial, you start with your highest power of x, your biggest degree, and then if you start with x to the fifth, then you go x to the fourth, and x to the third, and x to the second, and x to the third first until you get down to your constant term, which is basically x to the zero power. Okay, so y'all been doing that. It's just nobody ever really. I mean, we did kind of call it standard form, but this is like saying, all right, for any polynomial, it doesn't matter how big the power is. Okay, so what we're going to do, we're going to give you some examples. We're going to have you write an expression in standard form. So it's going to give you those directions here. We'll do 3 things, maybe 4 here. So let's write the expression in standard form. And then we're going to classify it by degree and number of terms. Oops, sorry. So we're going to write the expression in standard form. And really, once you do that, you'll see how many terms it has, and you'll see what your degree would be. Because again, it will be when you put it in standard form, the degree is going to be your first number that you have, which should be your highest power of. I think all these are going to make them x, just to keep things simple. So we've got 3x to the third minus x plus 5x to the fourth. Okay. And usually the only problem that people have with these is sometimes you'll get your signs mixed up, and you do have to remember that the signs go with the numbers. So the easiest thing that I always told people to do for this one is if you're figuring out your terms and figuring out what you have, always start with the number on the right side and make sure you basically just circle it. That plus 5x to the fourth is one term. Your minus x is another term, which then means that 3x to the third is a separate term. So if you circle starting from the right side to make sure you take that sign with this one, so we can move it around and get it in standard form, you've got 5x to the fourth is your highest power of x. The next one is you've got your 3x to the third. It doesn't have a sign, so we're going to basically put a plus there. And then your minus x would be at the end. And that way, when you circle each term as you're kind of going back and thinking about rearranging where they are, you already know what it is. You've got 3 circles, so it's got to be 3 terms. And with the terms, they may have you just put in a number, because again, sometimes they may also give you like a drop-down menu where you can do that one. But so this case, if we name it by the terms, we could say it's either 3, or they may give you a drop-down menu where you have to say trinomial. They shouldn't ask you to do both. They'll either give you a spot to put the number, or they'll give you a drop-down menu to pick, one of your options that's here. And if you name it by degree, well, that's 5x to the fourth. That's x to the fourth. Degree 4 means we're looking for 4 answers. Or if you go by the name of it, it's quartic. Okay. Everybody all right? So far, so good? Yeah, pretty straightforward, right? Nothing really tricky about these for the most part. I'll show you one here in a minute where it might get just a tiny bit tricky, or as tricky as they can make it. All right, so for example 2, let's go with 3 minus 4x squared plus 5x minus 10x to the third. Okay, and again, really the only thing you have to be careful of is, again, your signs have to go with the numbers. So that negative has to go with the 10. That plus has to go with the 5x, and that minus has to go with the 4x squared, which means the 3, again, is off over here by itself. Doesn't really have a sign, so we just got to know that there's technically a positive that would be there. Okay, so your highest power of x in this case is x to the third, so that's got to be first. We've got an x squared, we go next. We've got a plus 5x would be next, and what would be a plus 3 there would be your standard form. Okay, so there is your answer in standard form. All right, again, if you do that where you circle them, now you've got 4 circles. So if you name it by the terms, just 4. And again, that one, they'd have to give you a spot just to fill in the number because there is no name for a 4-term polynomial other than just saying it's a 4-term polynomial. That's all you can say. Okay. If you name it by degree, first term is negative 10x to the third, so your degree is 3. Again, they may give you 3, or they may give you the drop-down menu and have you pick and say that it's cubic.
Why is 4 the only term that you write?
If you name it, just about how many, the number of terms. So we had the 4 circles, so there's 4 terms. And again, there's no, after you get past 3 terms, there's no specific name. It's just a 4-term polynomial.
Okay.
So, yeah. Okay, now here's the only thing that would be a trick question. So we got 16x minus 10 plus 5x squared plus 12. Okay, if you start to go back and rearrange them here, we've got the 5x, the plus 12, the plus 5x squared, the minus 10, and then the 16x, which again would technically be a plus that's there. So we've got the 5x squared, the 16x. Now, if you get to these two, you're like, well, I got a negative 10 and I've got a positive 12. They're, if those were the two things, they're basically constant terms, right? Because they don't have a power of x. So you may be saying, which one do I put first? Well, if you've got two that are the same degree, can't you do negative 10 plus 12? Yeah, so just go ahead and combine your like terms. So if you have like terms, you've got to combine your like terms. So you can make that 5x squared plus 16x plus 2. So technically, that would be your standard form. So what starts off looking like it's got 4 terms, when you combine your like terms, you actually only have 3 terms. So it's 3 terms, or again, they may do trinomial. And then your highest power of x is x squared, so your degree is 2. But again, if it's degree 2, they may say it's degree 2, or they may say that's a quadratic. Okay, so if you have like terms, you've got to combine your like terms first. And that honestly is the only way they can give you anything that might be considered a trick question, that they may give you a couple like terms along the way, or you might have 3 or 4 like terms that you may have to combine together to make it be something shorter than what it looks like. But that's the only possible way that you could get something like that.
Did you say that doesn't matter what order we put it in, like as long as the like terms are next to one another? Like I could do 12 minus 10.
But if you have like terms, you combine them together. So you either add them or subtract them, whatever it says to do. So whether it was 12 minus 10 or negative 10 plus 12, you're still going to combine those together to make one term.
Oh.
So, okay. Okay. So there's just the basics where they kind of, go through everything that's there, kind of figuring out all the little parts and pieces of it. Okay, now here's where because we've been doing some graphs, here's where we're going to kind of start getting a little bit into graphs to figure out exactly what it is for sure, how we're going to set this thing up, and all the little parts and pieces that go with it. Okay, because when we're talking about the graphs, and again, we're kind of getting ready to graph trinomials, because right now the only thing we've graphed is x squared. We haven't talked about how to graph x to the third or x to the fourth or x to the fifth or x to the sixth or any of that. We're going to show you how to do that with this part or this particular section, this particular chapter that we've got that's coming up. The very first thing we're going to look at is not the overall part of the graph. We're going to look at just the end behavior of the graphs. And then after we do this for a couple of sections and everybody's had a chance to practice it, then we'll come back a little bit later on and talk about, all right, here's what happens in the middle. Here's how we figure out what's going to happen in the middle of this graph. And then we put it all together so you can see how this thing will look all together. All right, we're not going to play tic-tac-toe, but, yeah, I know. We're going to make a tic-tac-toe box here. Well, actually, that should have been a little closer. That's fine. That box probably should have been, it should be a little bit of a wonky tic-tac-toe box. You probably don't need as much room at the top. If you just make just a regular tic-tac-toe box, it'll be okay. Okay, so everything that we do for the end behavior of graphs, if we're talking about, again, just the end behavior of graphs, this is all based on your leading term. Okay, and what we should have said back here when we were talking about standard form, if you got it back here, if not, you can just kind of put it here. But back when we were talking about standard form, where we write the terms in descending order based on the degree, the first term is what they're going to call the leading coefficient. Should have said that back here and I forgot. If you don't have room to write it here, if you write it over here, that's fine. Just as long as you got it somewhere there close to standard form, that when we talk about standard form and you write the terms in descending order, the first term is what they call the leading coefficient because it carries all the weight. Basically, the degree, everything else that happens with that function or that equation, whatever it is we're talking about, is that first term has a lot to do with it. Just like when we were graphing quadratics, if that first term was negative, we knew it was going down. If we knew the graph was positive, it was going up. The A value told us if we had a max or a min, and that helped us determine what the range was going to be, if it was greater than or less than. So that first term always carries a lot of weight. So that's why they call it the leading coefficient, because it's going to lead everything else that we're going to do for this part. Okay, so if we go through this thing, that first term, that leading term we have here, based on what the first term is, that leading coefficient, okay, it's either going to be positive or it's going to be negative. All right, and then as far as how it goes, so we're either looking for the first term to either be positive or negative. The other thing we're going to look at for the first term is whether the degree is even or whether the degree is odd. Okay, so when we're talking about the end behavior of the graph, all you have to do is you look at just the first term, as long as it's in standard form. Okay, so if it's positive, now if you think about this one, the degree was even. that means we're going to have like x squared as your leading term. Think about when the first term was positive. What did we know the graph was going to do? Which way was the graph going? Left side was up, right side was up, right? So what we get to do in Math Excel is they're going to tell you just to do two things in this case. They're just going to say up and up. Because the first number is always going to talk about the left side of the graph. The second number is going to talk about the right side of the graph. So the left side is up and the right side is up. All right, and if we were doing x squared and the first number was negative, they're not up, they're down, right? So in that case, you would have down and down.
But if the degree number is positive,
Mhm.
like even,
Yep.
it's still gonna be down.
If it's positive and it's even, then it has to be both arrows are pointed up.
But why is it negative?
If it's negative,
And the degree is even, it's still gonna be
so think about if it was negative 2x squared. You put your vertex there, and then you're going to go down 2 over 1. So it's always going to be pointed down. So anytime it's negative, it's got to be pointed down. If it's positive, it's got to be pointed up. And that doesn't matter if it's x squared or x to the fourth or x to the sixth, because all these graphs back here are going to be kind of similar to x squared. And that's the one thing we got to get is that whether we do x to the second or x to the fourth or x to the sixth, if the first term has an even power, either they're both up or they're both down. Okay, now, and then if the degree is odd, if it's just x to the first power. All right, and for this one, think slope. So whenever your degree is odd, think slope. If you have a positive slope line, what does it look like? You do the airplane thing, right? If it's positive slope line, you know that the right side is going to go up, the left side is going to go down, right? So in that case, it's going to be down on the left, and then the right side is going to be up. Okay, if you think about a negative slope line, it's the opposite, right? The left side is up, and the right side is down. Okay, and again, that doesn't mean whether it's x or x to the third or x to the fifth, it doesn't matter what it is. If that first term has a power that's an odd power, there's always going to be one that's up and one that's down. And just and basically it's this: if it's positive, you know which side's going to be up. If it's positive, the right side is up. It's positive. If it's negative, then that means the left side has got to be up. So the sign of it tells you which one's going to be up. So if it's if we can block out what's in the middle there. Oh, here, this will work. There, that worked perfectly. Okay, if it's the first term is an odd power, if it's x to the first or x to the third, x to the fifth, you got to think slope. And what this is tells you which side is up. If the first term is positive, you know the right side is up. If the first term is negative, then you know the left side is up because we're either looking at the right side of the graph or the left side of the graph. Don't think about that. And somebody might be saying, well, how are they gonna do these questions? All right, here we go. Here's how it's gonna be. Okay, so they're gonna give you a function equation like this, where it's y equals negative 10x plus 5x squared. All right, and for end behavior, you only look at the first term. So basically, you think about putting it in standard form. So it's 5x squared. Now, if you put it in standard form, the thing is, though, everything after the first term, you don't even have to look at it. So you don't even have to worry about really writing it in standard form because all you need is just the first term. And if you look at the first term, here's where you kind of break it apart. The number in front tells you whether it's positive or negative. So it's positive. and it's x, and 2 is an even power. So if you had to graph 5x squared, we know it would look, from everything we did in quadratics, we know it would look like this. Left side's up, right side's up. So the answer for this one would be up and up. Because the left side will always be first, the right side will always be second. Again, you basically kind of go back and put the spots here. We got positive and even. There's positive, there's even. That puts you right here. So it's up and up. Okay, and again, today you may be going, well, okay, what are we doing? Again, you got to wait because this is only a bit of the graph. We're going to find some other parts and pieces, and we're going to put it all together in a couple of days. All right, so for example 2, let's go with y equals negative x to the third plus 2x squared minus 10x plus 5. All right, for a problem like this, it's already in standard form, so we don't have to worry about rearranging anything. All we got to worry about is first term. And again, just tell me, all right, what's the sign? Is it positive or negative? It's negative, and it's x to an even or odd power. So it's odd. So all you then is got to kind of, again, if it's odd, you got to think about slope. It's a negative slope line, which means it should look something like a negative slope line. So the left side is up, and the right side is down. And that's all you got to do. You say up, down, or down, up, or down, down, or something like that.
How do you know if it's? Oh, okay, never mind.
Okay. Yeah, that all. If you know if it's negative and odd, you just go back to the chart. It's negative, odd's here, so then that's where our answer is going to be right there. So you figure out first if it's negative or positive, which tells you which row you got to be in. If it's positive and even, you go here. If it's positive and odd, your answer's here. If it's negative and even, you're here. If it's negative and odd, then you're there. So I'd say figure out whether it's positive or negative first, and then just track it over to where you need to be after that.
What if it's 0?
They will not give you one where the first term is constant, because that's a trick question, because there is no up down, it's just flat.
A straight line.
Yeah, so that one they will never do that.
They won't ever do that?
No, you'll have to have an X in there somewhere.
Okay.
So good question. I've never had anybody ask me about that one before. So that's worth the starters. You catch?
Probably not.
There we go. Okay. Let's give you one more. I think it should be fun. All right. So for example 3, so negative 12 x to the third plus 16x plus 22x to the fifth minus 4. Okay, so really, again, all we need, if we're doing standard form, all we need is the leading coefficient or the leading term, which is your highest power of x, which in this case would be that plus 22x to the fifth. Again, if you've got your chart, it's positive, and it's x to an odd power. So positive, odd puts us here at down up. Okay, and for those questions in Math Excel, it's going to be really easy. They're going to give you 4 options, and you just have to pick which of the 4 options it is. Is it going to be up and up, down and down, down up, or up down? All right, last thing, because we're talking about graphs, you may have some turning points along the way, because the graph is going to turn, from negative to positive to increasing to decreasing. So, just like when we're doing quadratics, when we graph quadratics, you had a turning point here at the vertex. Oops, sorry. if we're doing, 5x squared, you would have a turning point at the vertex because you're here, you're going decreasing, or you're going down, then all of a sudden you get here, now the graph is increasing. So you'll have some turning points along the way. So when they talk about the turning points, oh, you can't see it though. Here we go. So we're talking about the turning points. The maximum number of turning points is the degree minus 1. So if you start off with x to the third, the most turning points you can have, if your leading coefficient's x to the third, the most turning points you could have would be 3 minus 1 would be 2 turning points. If it's x squared, the most turning points you could have then is 2 minus 1, which would be 1. And if you think about it, if it's x to the first, which is a linear straight line, if you do 1 minus 1, there's 0. There's no turning points because we know it's a straight line. It's a constant type thing. Now, you may not always have the max based on the numbers and how it goes for this one. So I'm going to show you just you don't have to write this down, but just kind of show you.
Is the degree minus 1, is that the highest degree?
Yes, you take your leading term,
Okay.
find out what that degree is. So the turning points would be then your highest degree, your leading degree minus 1. So like in this case, they're having, and we're not quite ready for this yet, but we're going to get there. You've got negative 0.5 x to the fourth plus 3x squared plus 2. The most terms you could have for this one would be 3 because you got degree is 4. 4 minus 1 will get you 3. To find those, you basically, as you start to plot points along in the graph, you basically go back through, plot some points, and then you figure out where that your points start to change from either an increasing or a decreasing kind of thing. And that helps you know that, okay, anytime it changes from increasing to decreasing, points wise and where they go, that's where you know that you're going to have some turning points along the way. So you'd have a turning point that would be here and then here and then there. So this one actually would have 3 turning points if you go back through that. But again, we're kind of getting there. And it's not a big deal because when you plot points, you'll kind of see it anyway. But sometimes they like to talk about that when you have turning points, that's where your graph is going to transition from being increasing to decreasing or decreasing to increasing. So there's, a change in the graph that you could possibly have there. And where you have those turning points, you could have a relative maximum or a relative minimum along the way. Because again, that's either a high point in the graph or a low point in the graph.
I'm just kidding.